Friends, today we'll discuss the topic of interference. Interference is the phenomena of overlapping, or we can say superposition principle. When the two waves arrive at a point, maybe of different or same amplitude in a same direction, then each wave produces its own displacement at that point. If any wave is coming like this, other wave is coming like this, if same phase are coinciding, okay, so it is crust and it is a trough, so you can say it is a trough. So in case of trough, the intensity will increase or amplitude will increase in a different direction, and you will get the high amplitude, and in this way you will get the high amplitude. This is the summing up, algebraic sum of the amplitudes. So it is called constructive interference. And if opposite phase are going to coincide, you will get the zero or less amplitude due to destructive interference. This phenomena was observed by very famous scientist, that is called Young's. So according to Young's, what happened? He observed the phenomena of interference of light, and in Young's double slit experiment, he explained the phenomena of interference of light through this experiment. He demonstrated the phenomena of interference of light. He took a strong light source, S, he named S, and parallel to this, he made two slits at equidistance. Means this distance is equal from the center. Means you can say this total distance is D, and the half distance is D by 2. This distance is D by 2. And he named this is S1 and this is S2, and at some point he observed he observed the interference pattern. He can go like this. This is the P point. So this is the S1P path and this is the S2P path. So he took a strong light source S. In front of strong light source, he made two slits, very fine slits, and these two slits become coherent sources when the S light source is illuminated. As soon as this light source is illuminated, these two slits become coherent sources, and through these coherent sources we get a constant path difference and the constant frequency, same frequency, so we get complete interference pattern. Because to get interference pattern, we need a fixed frequency or we need a constant frequency, so we get the interference pattern. Now what will happen when these two sources become coherent sources and emitting out some light, and this light gets superimposed, and due to superposition, due to interference pattern, the interference pattern obtained on the screen. This screen is XY screen, and on this screen we get the interference pattern. What is this interference pattern? This interference pattern is the bands of the bright and dark fringes, just like a bands. Okay. So on the screen we get alternate manner bright and dark fringes, dark and bright fringes. And when you see at the center of the screen, you get the bright fringe. Because from this and from this, we get path difference 0. Due to 0 path difference, because from this point to this point and this point to this point, we get a path difference 0. And we get maximum intensity of light, and we can say it is a bright fringe. And due to 0 path difference, we get the same phase that coincide at this point, and due to same phase coincidence, you get a bright fringe. Okay. We came to know about the Young's double slit experiment. According to Young's, he demonstrated the phenomena of interference of light. And the screen he got interference bands or interference fringes. At the center he got bright fringe, and above and below alternate manner he observed bright and dark fringes. According to Young's, when S source, strong monochromatic light source, illuminated, the two holes becomes coherent sources. Coherent sources gives constant frequency, so we get a interference pattern on the screen. Now S source and S1 and S2 become coherent sources, and due to this we get number of fringes on the screen, that is called interference pattern. At the center of the screen you get the bright fringe because the path difference is 0, and due to 0 path difference same phase coincides, and when the same phase coincides we get a bright fringe. On the screen where the same phase coincides you get the bright fringes, and opposite phase coincides you get the dark fringes, because due to same phase coincidence you get interference pattern, you get a constructive interference, and you get the intensity, high intensity light, and that's called a bright fringe. And when the opposite phase coincides, means one has a crust and the other one is a trough, or trough and crust, they coincides, they superimpose, and they form a dark fringe. In this way, in an alternate manner, you get bright and dark fringes on the screen. Now we are considering a P point where any fringe can be observed. Any fringe can be obtained, whether it is a bright or dark, anything else, but you will get any fringe on the screen. If P point having the same phase coinciding, means bright fringe maybe, or opposite phase coinciding, you will get the dark fringe. So consider any fringe may be there, we can say any band, whether bright or dark. Now, before knowing this, how to get the derivation to be done without any complications, without any tension. So we need to learn something to remember this derivation in a simple manner. First, you need what you need to derive this derivation. First point, use two triangles. That should be right angle triangles. And this right angle triangle apply hypotenuse square is equal to perpendicular square plus base square. This formula you have to use. Next point, what you need to do? You need to get the path difference. So that this S1P and this S2P. S2P is the bigger path and S1P is the smaller path, and difference is subtraction. So what you will do? S2P minus S1P. This you need to find out. And path difference can be represented by delta. This is a del. This you can say either you can draw del or you can write S2P minus S1P. One more thing, when you use this point as the central fringe, and this point is a P point, is a point where we got the fringe. Now to draw perpendicular on the screen. This is the perpendicular on the screen. This distance will be d by 2 and this distance will be d by 2. Now see, when we see two triangles, we have to name it P, Q, and this is R and this is O point. Okay. Now see, if we consider this triangle S1 PQ, we have got a very small triangle, that is a right angle triangle S1 PQ. Another triangle you can see, this is S2 PR. This is another triangle. So we have two triangles, and what I told you in the starting period. So here, when you take this triangle, the PQ distance would be the perpendicular, and you don't require this point. So this total distance would be x. From the top to center, distance would be x. So if you want this arm only, if you want only PQ, you can write x minus d by 2. But in case when you need this arm, you have to add this. So RP or PR would be X plus D by 2. These two things you have to remember, and D is the distance between slits and capital D is the distance between one slit and the screen. These slits and the screen distance would be capital D. These things you have to remember. Okay. So you better know. I think you are aware of this. On the screen, same phase coinciding, bright fringe obtained, opposite phase coinciding, dark fringe is obtaining. Now, what we need to remember to get this done, you have to draw a perpendicular, you have to take two triangles, and you have to subtract D by 2, and you have to add D by 2. And that D is the small letter D, and this small letter D is the distance between slits. Okay, now you have to use two triangles and use the formula hypotenuse square is equal to perpendicular square plus base square, and the path difference S2P minus S1P. One more thing I want to tell you, keep in mind, if this P point coincide at this point, then this distance is very much smaller than this distance. This distance is up to 1 meter or 100 centimeter, and this distance in millimeter. So this distance would be equal to this central distance, because this distance is negligible, because this distance is too large. So this point you have to consider when P point coincides at O. Okay, that time you need to put S1P is equal to S2P. This condition you need to use, and this is called up to the capital D. So before if you want to do this derivation, you must remember these two facts. These two S1 and S2 source are the coherent sources. They are throwing light with a constant path difference, and at the center you get the bright fringe, because the same phase coincide due to the path difference 0, and above and below you will get the alternate manner, the different fringes, bright and dark, all having the same width. Now what we need to go further, if you want to get bright fringe, condition for bright fringe, before doing derivation we are remembering something, so this derivation would be very easy. For a bright fringe you need to do path difference is equal to even multiple of lambda by 2 or integral multiple of lambda. If you say even multiple of lambda by 2, that was fantastic, because it will give you a good idea. Even multiple means in maths, you multiply any number with n, you will get the even number 2n, that is 2n lambda by 2 or integral multiple of lambda. Means 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, 8 lambda, 21 lambda. Whatever the lambda, you will get the path difference is equal to even multiple of lambda by 2. You will get bright fringe, definitely. And in case of dark fringe, what you need to do? You need to do 2n minus 1 or 2n plus 1. You multiply any number with 2, you will get the even number, like 2 into 5, 10, 2 into 11, 22. Whatever you multiply even or odd number with the 2, you will get the always even number. But when you subtract 1 or when you add 1, you will get always odd number. For example, I will take 10. 2 into 10 you will get 20. Minus 1, 19, plus 1, 21. So, when the path difference is odd multiple of lambda by 2, you will get the dark fringe. This is the condition you get dark or bright fringes on the screen. But, after some time, we need to get the fringe width. Width of the fringe. Okay. Just like belt, this is the width. Okay. Now see, for fringe width, you subtract two fringes. If this is bright fringe, if this is bright fringe and this is a dark fringe. If I subtract this fringe and this fringe, you will get the dark fringe. If two consecutive bright fringes will be subtracted, you will get the dark fringe. If two consecutive means one by other, means 2/3, 4/5, 6/7, these are the consecutive numbers. So consecutive bright fringes subtract, you will get the dark fringe width, or consecutive dark fringes subtracted, you will get the bright fringe width. So fringe width is a different condition, and to get the fringes is the different condition. On this fringe, if you are getting bright fringes, means something is there, means we have got a path difference, and that path difference is equal to even multiple of lambda by 2, you will get the chances of bright fringe. Odd multiple of lambda by 2, you get the chances of dark fringes. Okay, but you want the fringe width, you want to calculate the size of the width or width of the fringe, you subtract the distance between two bright and two dark fringes, you will get this. So we have got the complete idea of the derivation. Now we will solve the derivation in the simplest way. So please just turn the camera so you will get the concept easily. Now I will solve this side so you will come to know. Now here you can increase this portion, because when you can enlarge this, because this is a good mobile, you can enlarge this. Now here we are going to get the derivation that to be done, and it should be very easy so for my lovely students, because I know you all guys are very willing to get the concept in a simplest way, so you can remember for a long time. So see, if we have this derivation, I will rub this little portion, so I get concept on this portion, and this I will rub, so I will get the solution to be done. Now this portion I will solve. Okay, now I will rub this, so I will do the derivation. Now you keep in your mind the distance between two slits, small d, and distance between slits and the screen is capital D. Now what I will do, I will use Pythagoras theorem as I explained in earlier lecture. S1p square is equal to, see, I won't write S1q, I directly write D, capital letter D. That would be D square. I won't write PQ, I will write directly x minus d by 2 plus x minus d by 2 ka whole square. So you will get S1p square is equal to so and so. Next, S2p square is equal to d square plus x plus d by 2 whole square. This is the Pythagoras theorem, means we are getting the path on which up to which the light traveled. So subtract them, S2p square minus S1p square, you will get 2xd by 2xd. You will get 2xd. You will get 2xd. If you subtract them, you will get 2xd. Okay. X is the distance from central fringe. Keep in your mind. X is the distance from central fringe to the whatever the fringe you observed on the screen. Now use the formula a square minus b square. So I will use S2p minus S1p is equal to 2xd upon S1p plus S2p. Whatever the positive word you keep this side, and whatever the difference you keep this side. So this difference would be the path difference what we studied. Now I explain one thing. When P point coincide at O, then this distance would be equal to this distance, and that is equal to capital D. So you can put D plus D, you will get path difference is equal to 2xd by 2d. So 2 will be cancelled out. You will get xd upon capital D. D is the small d is the distance between slits, and capital D is the distance between slit to the screen. Okay. So we have got the master key. Now we will open the lock. We have got the master key. So X is very important thing you have to remember in your brain. Small letter X. X key by capital D is equal to, if you want bright fringe to get, bright fringe, there is a bright fringe. Okay, we are going to find the bright fringe. There is chances to get the bright fringe. Xd by D equals to even multiple of lambda by 2, or you can put an integral multiple of lambda, that is n lambda, because 2 will be cancelled out, you will get the n lambda. So you will get what is the distance from the central fringe. You will get x is equal to n lambda d, capital D upon small d. If somebody will ask you a particular light having wavelength 4800 angstrom. If you have light 4800 angstrom and the distance from the slit to the screen is 1 meter and the slit is 1 mm, that time they will ask you where you will get the bright fringe, above the center fringe or below the central fringe. It's okay, fine. I will put the formula. But one thing they didn't tell. That is the 5th bright fringe, 8th bright fringe, 20th bright fringe. They didn't tell. So they will tell you which one is the bright fringe. Where we get the bright fringe, 7th number bright fringe or 20th number bright fringe. In place of n, you put 20th number or 7 number. You will get the position of bright fringe from the central fringe. Very simple. No tension. Okay. So from the central to certain height, whatever the number of bright fringe, you will get answer. So if you want to get the distance of bright fringe, 7th number above the screen, you put 7 in the place of n. If 5th number below the screen, central screen, you will get 5. And solve them and add them, you will get the distance between two bright fringes. If both bright fringes is up or both bright fringes is down, and they are demanding you, they are asking you the distance between two bright fringes, so what you will do? What you have to do, if it is 5th number, it is 8th number. So 8 minus 5th, whatever the distance, you will get the distance between two bright fringes. So this is the current position of bright fringe. Now, if it is x position for the nth number, if 5th bright fringe is 1 and 6th bright fringe is 2nd, so 5 plus 1, what you will get? 6. So another one is xn plus 1. This is xn. This is xn. And this is x plus n plus 1. Consecutive bright fringe. You will get n plus 1 lambda d upon small d. Subtract them. xn plus 1 minus xn. This is called fringe width. In your books, you can find capital X also. Beta or capital X. This is the fringe width. How much width is the bright or dark? This fringe width. That will be lambda capital D upon small d. You subtract them, you will get this answer. In case of dark, same formula you need to use. What you will do? I will do here. That is xd by capital D is equal to 2n minus 1 lambda by 2. Got it? Now, just you get the value of x and what are the two consecutive dark fringes? Take one is a 2n minus 1 and another one 2n plus 1. If it is x plus 1, that is 2n plus 1. It is xn, means 2n minus 1. And subtract them, you will get the same answer. This is the Young's double slit experiment for the fringe widths, and Young's demonstrated the phenomena of interference light. He took strong light sources. In front of this light source, he placed two slits. They become coherent sources, and these coherent sources produces same frequency. So you get the interference pattern to be done on the screen. That is the bright and dark fringes on the screen. And you need to get the path difference, and the path difference is even multiple of lambda by 2 or integral multiple of lambda by 2. There is a bright fringe. If odd multiple of lambda by 2, that is a dark fringe. Subtract them, you will get the fringe width. Have a nice time. God bless you all. Bye bye.